upon starting up, Aurora will search for devices that are already connected to the computer. If it doesn't find any, you'll be taken to the device selection page. At this point, you'll want to turn on your NIRSport 2 and either connect via the USB cable that's provided with the system or via Wi-Fi. To connect via Wi-Fi, you'll head to your computer's available Wi-Fi networks and you'll select the NIRSport 2 network. Now, the username and password for this Wi-Fi network are printed on the bottom of the device. In my case, my computer already knows the password, so I don't have to type it in. Clicking out and clicking back in, we will see that the connection is secured. Coming to the Aurora main page again, I can refresh list, and I will see my device available for connection. Note here that it says parentheses wireless. If this was a USB connection, it would say parentheses USB. So I can double click this to select the device, and I land on my configuration page. Now before I get into configurations, I want to show you a couple other things in this application. You've got this device status bar in the bottom of the screen. Coming over here to the settings wheel, there are various application settings to take note of. We have data, root, and configuration directories, which can be changed. We have plotting colors for visualizing data and various labels in Aurora. We have detector type, which determines the dark noise thresholds for the signal optimization routine. So you must set this to the proper detector that you actually have. We have various application settings here. One I highly recommend is enabling preview mode. We have access point connects to, which allows you to connect the NIRSport 2 to an access point so that you can bolster the Wi-Fi connection. We've got security. This lets you set a password in order to edit any configurations. Coming back to the setup page, we can now create a configuration. So there's some defaults available here, and we can click on them once to look at various details on them. But we'll want to create a new one by coming down here to the bottom left and selecting New Configuration. Montages that are available to us in our configuration directory will be listed here, and we can select the one that we want. We'll give it a name. We'll select how many devices we're using for this recording. In my case, I'm only using one, but if I had multiple devices in tandem, I would declare them here. How many 16 devices and how many 8/8s I had. I'll also declare if I'm recording with any accessories, including short distance bundles or an accelerometer. Now these are additional hardware, and if you have access to them and you are including them in your setup, you do want to declare them in the software as well. Okay. And now we can edit some parameters in our configuration by coming here to the Edit button. Advanced parameters, this allows us to set the illumination pattern and the sampling rate of our recording. We can change the sampling rate by moving this ticker, and we can change the illumination pattern manually or using this bilateral pattern option. We can reset it to default if we'd like. Coming to basic parameters, we can assign colors to various triggers here. Over in channel names, we can declare specific names for the channels. And if we're using accelerometer, we want to make sure that this option is declared in order to visualize the accelerometer data. Coming over to LSL stream names, we can declare the data out stream name, the trigger in stream name. We can also test the LSL connection for triggering if it's available, and set the fallback trigger number if a trigger other than 0 through 255 is sent to Aurora. This is the number that will appear. Okay, and if we've made any changes, we want to be sure to click Save. And now we have our final product, our configuration with some various details here, including the device type, the number of sources and detectors, the sampling rate, and so on. And now we're ready to optimize our signal, so we can select this configuration. Once the cap has been placed on the subject and they're ready for measurement, you'll need to run the signal optimization routine. This routine determines the optimal source brightness that yields the highest signal-to-noise ratio in each channel. It also tells you at the end various metrics which indicate which channels and their consequent optodes might need adjustment. The results are given on a color scale, with green being excellent, yellow being acceptable and okay to proceed with, critical meaning you should check the channel before proceeding, and saturated meaning the signal is saturated. Again, that would require adjusting the optodes, though that is an unlikely occurrence. So the results are given in 4 separate panels: signal level, dark noise, source brightness, and coefficient of variation. You're given the metrics for each channel and wavelength. And you can learn more about these various metrics in the Aurora user guide. On to data recording. We're first prompted for some information on the subject. This information will be saved with the rest of your data in a text file. Here we are on the stacked line plot view. This is a view of all channels plotted together. We can adjust the zoom and the scale of the plot in order to get a better sense of the variation in the data, as well as the time window. We can scroll down to view all of our channels separately. And what we're looking for in a high-quality channel is the presence of heart rate, which is that 1 Hz oscillation that we're seeing in these channels. Coming to line plot, we can decide to display hemoglobin or raw amplitude data. We can change the scale of all channels ourselves, or we can select auto scale, which sets the scale, the optimal scale for each channel. We can enable or disable a low-pass filter. We can change the cutoff of this filter by moving this slider, and putting it below 1 Hz will remove the heart rate oscillation. Note that any changes you make to the visualization in Aurora make no difference to the raw data that's saved. Aurora always saves data in its raw format, no matter what visualization changes you make to, say, filtering the data or changing its scale. And now to the topo plot view. The topo plot shows us basically a heat map of our data. It's just the amplitude of the data reflected in a color scale. We can set this to a more or less sensitive scale, and we can also decide if we want to visualize HBO, which is oxyhemoglobin, or HBr, which is deoxyhemoglobin, at one point in time. Moving on to 3D plot, that's that same information, it's just the amplitude of the data, but here we have it plotted on a 3D head, and the channels are represented as splotches over the brain rather than just one line. Again, we can change the color scale of this plot to make it more or less sensitive. If we hover over any of the channels, we'll see the line plot of the data in that channel as well. We can decide if we want to look at HBO or HBr with that color plot. Coming down to visual settings, we can decide if we want to look at all 10.5 landmarks, just 10.10 or 10.20, or turn it off. We can opt for looking at all these various labels, showing the brain and showing the scalp or not. We have visual shortcut keys, so if you want to get a particular view, as well as this auxiliary view button, which will bring up multiple instances of this plot. And now onto the accelerometer tab. Note that the accelerometer can discern where it is in space on its own, and thus you can record accelerometry data without having to even look at this screen, let alone hit the calibrate button. What the calibrate button here refers to is setting the frame of reference for Aurora to visualize the data and the movements of the participant's head. And so you can properly calibrate this by asking the participant to sit relatively still. Click the anterior button under Views, then rotate the set anterior wheel until the head model sits level on the screen. The process may need to be repeated once or twice before getting a stable, accurate viewing so that the head movement of the subject is reflected in the head movement of this model. Back in our line plot view, we'll watch as some triggers appear via LSL. We can see that we have incoming triggers in the status bar on the bottom, what the name of the trigger stream is. The triggers will appear as lines through the time course, and we see the first trigger here, and we note that it's a 1 as we are told by the trigger indicator on the bottom. And we'll wait shortly, and we will get another trigger 2 to signal the start of the next condition. Okay, now heading over to block averages, we can see the average response to our stimuli. We have the responses to trigger 1 and trigger 2. And if we hover over any of the plots, we can look at the individual average responses for each channel. By unclicking auto scale, we can see the responses amplitude relative to each other. By adjusting the time window, we can adjust the window over which the response is plotted.